So hello dear students. So today we will do some problems based on the two chapters, that is units and measurements, and the other chapter is one dimensional uniform motion. So we'll start with units and measurements first, and this is the first question that we are going to do, and this is based on dimensional consistency. Okay, so the question is that you have a quantity Q which is related to the different dimensions like this. So it is related like this: k m raised to power a, l raised to power b, t raised to power c, and the acceleration due to gravity raised to power d. Okay, so you have a quantity which is related to all the dimensions in this particular fashion, and then it is given that q has a dimension of pressure. Okay, so what is required is we have to find out the values of A, B, C, and D. So these values we have to find out. Given that the quantity Q is related to these dimensions and the acceleration due to gravity in this particular fashion, and also Q has got the dimension of pressure. So what is pressure? So you know the pressure is basically force divided by area, and force is basically mass times acceleration divided by the area. So what is the dimension of pressure? So pressure's dimension becomes then the dimension of mass, then dimension of acceleration, and acceleration is velocity divided by time. So it is distance divided by time square. So it is L t raised to minus 2, and then you have area which is L raised to power minus 3 in the denominator. So if you combine all of them, so it becomes, pressure becomes M L raised to power minus 2 and T raised to power minus 2. So this is the dimension of pressure. Sorry, it is length squared, area is length squared. So it is raised to power 1 minus 1. So this is the dimension of pressure, M L raised to power minus 1, T raised to power minus 2. And then you have to compare the coefficient. So Q, which has got the dimension of pressure, is simply M L raised to power minus 1, T raised to power minus 2. And this is to be equated with this given dimension, that is K, which is dimensionless, M raised to power A, L raised to power B, T raised to power C, and G again is acceleration due to gravity. So that becomes again L t raised to power minus 2 whole thing raised to power d. So we can combine the like terms, as you say, that is mass on in one single entity, then L as a single entity, and T also as a single entity. So we have to combine the powers. So it becomes m. So there is just one m. So it is m raised to power a. Then L is, there's an L here and an L raised to power d here. So it is L raised to power b plus d. And then you have t raised to power c minus 2d. Okay. So this has to be equated with m L raised to power minus 1, t raised to power minus 2. Okay. So then you have these equations that you can derive. So since m raised to power 1 on the left hand side and m raised to power a on the right hand side, so a becomes equal to 1. That is the first equation. Similarly, again, L is raised to power minus 1 on the left hand side and L is raised to power b plus d on the right hand side. So b plus d is equal to minus 1. And simply t is raised to power minus 2 on the left hand side, and on the right hand side it is raised to power c minus 2d. So then it becomes c minus 2d is equal to minus 2. So there are three equations now, number 1, number 2, and number 3. And we have three unknowns. So simply you can find out all the three unknowns. The first one is already solved, a is equal to 1, and you can solve the other two to get b, c, and d. Uh, Also, what is given is your d is 1. Okay, so let us say d is equal to 1, and then in that case, you can substitute the value of d and then get the value of b and c. So b becomes minus 2 if you solve, and c becomes 0. Okay, so it is given that the value of t is 1. So you just substitute, you have four unknowns actually, a, b, c, and d, and the value of t is already given to you. A has been calculated, which is equal to 1. So when you solve for c and d here, you will get the value of b as minus 2 and c as 0. So this is basically dimensional consistency that we are dealing with. On the right hand side and on the left hand side, you should have the same dimensions. So in that case, on the left hand side, you have the dimensions of pressure. So on the right hand side also, they should be the dimension. The total dimension should be of pressure. And so if it is of this form, then the value of A, B, C can be calculated. And so that is how you do it. Okay. So now we are going to do another problem that is based on percentage error. And that too in a derived quantity. Okay. So what is given to you is that you have a sphere of radius, the sphere of a radius 10 centimeters with an error of plus minus 0.1 in centimeters. So you have a radius, a sphere with a radius of 10 centimeter and an error of 0.1 centimeter plus minus. And what is required is to calculate the errors in the surface area and in the volume. So to calculate the error in surface area, you know that the surface area of a sphere is given by 4 pi r square, and you need to calculate the percentage error, okay, not the absolute error but the percentage error. So you know that the surface area is given by 4 pi r square, and so the percentage error would be delta A by A, okay, into 100 of course. But first let us calculate delta A by A. And you know that surface area is 4 pi r square. So d of the surface area would be equal to 2 into 4 pi r dr. So if you take the derivative or the differential of the surface area, that is represented by 2 into 4 pi r dr. So just use this here. So you get 2 into 4 pi r into dr over area, which is 4 pi r square. So basically this 4 pi cancels with this 4 pi, 1 r cancels with this r. So you get this as 2 into delta r over r. So once you have this, you know what is delta r, you already know it is equal to 0.1. So it is 2 into 0.1 over r, which is 10. So you get how much? You get 0.02. So the percentage error is 0.02 into 100, which is equal to 2%. Okay? So similarly, if you want to calculate the error in the volume, the percentage error in the volume, you will know that delta V over V, again using the same, using what you call as V, as you know V is equal to 4 over 3 pi r cube. So then just taking the derivative, delta V over V would be equal to 3 delta R over R. So you know this, so you can use this to calculate 3 into delta R over R, which is equal to 3 times 0.1 over 10. And then from there you get delta V over V is equal to 0.03, and the percentage error in volume becomes 3%. This is in surface area. So this is 2%, and this percentage error in the volume is 3%. So this is how you calculate the percent error in derived quantities. Like for example, R is a given quantity to you, and the error is given in that quantity, and the quantities like the surface area and the volume are the derived quantities, which are derived from the radius. So surface area is derived or calculated from the radius. Similarly, volume is also calculated from the radius. And then from those derived quantities, if you know the error in the parent quantity, then you can calculate the errors in the derived quantities like this. Okay? So now let us do number 3 problem, that is the order of magnitude trap. Okay? So what is required in this kind of problem is that you are given some data, like for example, what is the density of air in a given room and the dimensions of that room, that is the length, breadth and the height of that room, and you want to know what is the order of magnitude of the number of molecules of air inside that room. So what is the order of magnitude of the number of molecules? Okay, so what power of 10 you can say is the number of molecules which are present in this particular or any room, for example. So let us say it is given that you have a classroom of dimension 8 meters into 6 meters into 4 meters. So this is the dimension of a classroom, and the density of air is given to be and it is given to be 1.3 kg per meter cube. This is the density of the air, and the molecular mass of the air is given to be approximately 29 units. So average molecular mass, since air contains a lot of molecules, different molecules, so each molecule is going to have a different molecular mass. So an average molecular mass of the air is 29 units, atomic mass units. Okay. So then what is the what is, let us say, mass of one molecule of air? So since 1 unit is equal to 1.66 into 10 raised to power minus 27 kg. So 1 unit atomic mass unit is simply this much. So then 29 units would be equal to 29 into 1.66 into 10 raised to power minus 27 kg. And let us say how much is the total mass of air inside the room. So you know the density of the air and you know the volume. So from there you can calculate the total mass of the air inside the room. So let us say the volume is 8 into 6 into 4 meters cube, which turns out to be equal to 192 meter cube, and then the density is this. So the mass is density into volume, so it is 1.3 into 192 kg. So it turns out to be equal to 250 kg. Okay. So now the total mass of the air is 250 kg inside the room, and mass of one molecule is this, which is equal to approximately equal to 5 into 10 raised to power minus 26 kg. Okay. So the number of molecules would be simply total mass divided by the mass of one molecule. So the total mass is 250 and the mass of one molecule is 5 into 10 raised to power minus 26, both in kg. So then you calculate to get this to be equal to 5 into 10 raised to power 27. This is the number of molecules. So the order of magnitude is 10 raised to power 28. Approximately 10 raised to power 28 molecules are present inside a room with this much of dimension, and if the density of air is 1.3 kg per meter cube. Okay. Okay, now we come to uniform one-dimensional motion. So we'll do a problem of relative motion here now. With a time lag. Okay. So we have one-dimensional uniform motion and we are talking of relative motion now. Okay. So basically relative motion means that two objects are moving with respect to each other and we are understanding what is the relative motion between the two objects. So the problem is that you have a car A. Okay, so you have a car A which starts from rest. Okay, so it starts from rest and it starts with a uniform acceleration of 2 meters per second square. So the acceleration is 2 meters per second square. This is the acceleration of the car. So it is moving starting from rest with this much acceleration. And then 2 seconds later you have a car B which starts at 2 seconds later. So car B starts at 2 seconds later and it has got a constant velocity. So velocity of the car is 10 meters per second and it is constant. So car B starts, now it is not accelerating, it is only moving with a constant speed. So what is asked is, what would be the time when B overtakes A? So the time when B overtakes A. So that is the question that is being asked. So let us say distance covered by A. So you know, let us say for A, the distance covered x A is given by this equation of motion ut plus half at square, and then you know that u is 0, so this term goes to 0, this is 0 because u is 0. So x of A is simply half at square, which is equal to, since A is given to you, it is half into 2 t square. Okay. Then for B, which starts 2 seconds later, so x of B is going to be V times t, of course, but that the t is 2 seconds later. So the V is 10 meters per second and the time starts 2 seconds later. So it is t minus 2. Okay. So this is the equation of motion for B. and he's asking the question when B will overtake A. So what would be the time at which the coordinates of the B would equal the coordinates of A? So the car A and the car B, both of them are going to match their coordinates, or the distance, or the, rather you can say that it's moving in one dimension. So the x coordinates become same at what time? That is the question. So we can just equate the two. When xa becomes equal to xb, so it would be at half into 2 t square, which will which has to be equal to 10 into t minus 2. So then you get t square is equal to 10 t minus 20. Okay, so you have a quadratic equation. So from here you get t square minus 10t plus 20 is equal to 0, and this would be satisfied if you solve this quadratic equation. T would turn out to be equal to, it's a simple quadratic equation, you can solve it. It will turn out to be equal to 5 plus minus root 5. So this is the answer. And then, of course, the valid answer is t is equal to 5 plus root 5, not the negative 1. Okay, so it would be, if you take the negative 1, it will be less than 2, and the time can never be less than 2 seconds, because uh, the second car started after 2 seconds, so it's going to meet the other car at a time later than 2 seconds. So the negative uh, wala solution, that is t is equal to 5 minus root of 5, is not the valid solution. The valid solution is 5 plus root 5. So this is the valid solution. Okay, and when you calculate it, you will get t is equal to 52.4 uh, rather. No, this is not the calculation. Let me just remove this. What is asked is the distance. Okay, so the time is given to you. So the position would turn out to be equal to x is equal to t square. Okay, so here you get x is equal to t square here. So then you just square it, 5 plus root 5 whole square, and it will turn out to be equal to 52.4 meters. So the position at which the two objects will meet after a certain time, and the time would be 5 plus root 5 seconds, and the position would be 52.4 meters. Okay, now we will do another problem, that is average speed versus average velocity. So the question that is given is that a particle travels from point A to point B. So there's a straight line, and there's this point A here, and then it moves to point B. Okay, so in the forward journey, its velocity is v, and then it returns from B to A, and then the velocity becomes 2v. So he's said that the particle moves from A to B with velocity v, and in the return journey from B to A, its velocity is 2v, or rather the speed is 2v. So in the forward direction, the speed is v, in the backward direction, it is 2v, and we want to find out the average speed and the average velocity. So let the distance, of course, is d. So let us say AB is equal to d, the distance. And what is the time taken from A to B? So the time forward is simply distance divided by velocity, which is d by v. And the time backward is again the distance divided by velocity, or the speed. And you know the speed in the backward direction is 2v, so the distance remaining the same, so it is d by 2v. Okay, so the average speed, as you know, is given by total distance divided by total time. So then you know the total distance is 2d, that is from A to B, and then from B to A. The total distance is 2d, and the total time is time forward plus time backward, which is d by v plus d by 2v. Okay, so then you calculate it, you will get the average speed as 4v by 3. So that is the average speed. And what about the average velocity? So the average velocity is the total displacement divided by total time. Okay, and you know the total displacement from A to B and back from B to A is 0. So the total displacement is 0, and whatever is the time t for that, so you will get this as 0. So the average velocity is 0, average speed is 4v by 3. So this is how you calculate average speed and average velocity. So the net displacement turns out to be 0, so that average velocity turns out to be 0, whereas the average speed, it's the way you calculate by total distance divided by total time. So you have to calculate the total time, and then you divide total distance by total time, and you can get the average speed. Okay, now we are going to do another problem, that is the meeting point with opposite accelerations. That is, we have done a problem like that. So in that, what is given is there are two particles, particle 1 which moves with a uh, uh, constant velocity, and that is u, and particle 2 and that particle 2 moves with a constant acceleration. So they both move in the same direction and they start at the same time also. So both of them start simultaneously, one with a constant velocity and one with a constant acceleration. And of course, they are going to meet again at a certain point. So when are they going to meet? At what time are they going to meet again? So that's a simple problem. A problem like that we've done already. So at time t is equal to 0, they are meeting, of course. And they are going to meet again at another future time. And what will it be? So, for the particle 1, x1, the displacement or the distance covered is u times t in one dimension, uniform motion with uniform velocity. And x2, for the accelerated motion, again, since it starts with zero velocity, so it would be half a t squared. Okay, and so you have to equate the two to get the future time when they meet again. So ut is equal to half at squared. And so you take it on the other side, you get t times half at minus u is equal to 0. So there is one solution, which is t is equal to 0 will give you this, satisfy this equation. So t is equal to 0 already satisfies, and they meet at t is equal to 0. But there is another solution, that is t is equal to 2u over a. And at that particular time, again, this particular factor is going to be 0. So at this particular time, again, you are going to, the two particles are going to meet together. So the future time when they meet together is 2u by a. Okay, now we'll start with another problem, that is motion with reversal. Okay, and in this, what is given is that there is a particle which is thrown upwards with velocity u. So particle is thrown upwards with velocity u, and then what would be the time taken after the time of maximum ascent? So if the particle ascends to this height, let us say, and then returns back. So what is the time taken? Let us say it starts at time t is equal to 0, and then it reaches this height and then comes back. So at any particular distance or at any particular time, what would be the time taken after it has moved its maximum to the maximum height? So let us first of all calculate the time of ascent. So the time of ascent would be given by simply this. You know that the acceleration is g, so gt is equal to u minus v, or rather v minus u. Okay, so gt is equal to v minus u, and v is 0. So time of ascent turns out to be equal to 0 minus u over g, and since g is in the negative direction, so it is minus u over minus g, which is u over g. So that is the time of ascent. So this much time it has taken to reach the maximum height. And then after that it returns to another particular position below the maximum height, and then the distance downward, or the time that is taken downwards. So time remaining, it is t, which is equal to t minus ta. So whatever time it takes it after it has reached the maximum, and it has taken time ta to reach that maximum, then the future time after ta would be equal to t minus ta. And the distance covered here would be simply sa, which would be equal to half g into t minus ta whole square, because after it reaches the maximum height and when it starts returning, to start with it has got a initial velocity as 0. At the maximum height the velocity is 0, so it starts from the maximum heights and starts falling. So then it would be given by this equation. The distance covered would be sa, which would be u for this particular downward motion is 0, the initial velocity for the downward motion is 0, so it will be just half g into t minus ta whole square. Okay, so then you have, this is the distance, and what is the distance here? The distance of the maximum height, you can calculate it like this. The maximum height, the distance s, let me call it s a, and this is s, let me just use s1 and s2. This is s2 and this is s1. So this is the maximum distance or the maximum height. So how will you calculate the maximum height since you know the time of ascent? So S is equal to UTA plus half GT square. So you just plug it, that U is whatever, it is U of course given to you, and TA is U by G, okay, plus half, and what is G? G is given to you, and T square again is U by G whole square. So it turns out to be equal to, if you calculate it, it turns out to be equal to U square over 2G. Okay? So it is like this. Of course, there is a minus sign here, not a plus sign, because G is negative. So I have made a mistake here. So there is a minus sign here because G is negative in the downward direction. So that is how you will get S1 as U square by 2G. So now you have these two equations, S1 and S2. So you can calculate S. So the total distance is S1 plus S2, which is S, and it is equal to, you just substitute the value of S1, which is U square by 2G, and of course substitute the value of S2, which is half G T minus TA whole square, and of course the value of Ta is given to you. It is U square by 2G plus half G T minus Ta, and Ta is given to you. It is equal to U by G whole square. So this is the total distance as a function of time in the downward direction. So the total time taken is t for the motion, then the distance would be s, which would be given by this particular equation. Okay? Okay, we will do this last problem now. Let us say if a particle is moving and the position as a function of time for this particle is given like this. It is a t cube plus b t square plus c. So this is the equation of motion rather minus, it is given here. So it is minus here. So this is the equation as a function of time with position as a function of time. It is given to you here. You have to find the average velocity now. You find out this average velocity between x is equal to 0 and, or rather t is equal to 0 and t is equal to capital T. So the time lapsed between the initial and the final stage is capital T, and this is the time that has lapsed between the two different points. And then you have to calculate the average velocity between these 2 points. So of course V average is equal to total distance divided by total time, or total displacement, divided by total time. Okay, so the total time is of course capital T, and what is the total displacement? It is simply the value of the displacement at x is equal to t, capital T. So it is equal to a times t cube minus b times t square plus c. That is the total displacement. And then of course you divide it by the total time, which is t. So once you do it, what you will get is a t square minus bt plus c. So this is the velocity, average velocity that you get. Okay, so we have covered a few problems here now on the two chapters, that is units and measurements and uniform one-dimensional motion. And we will, in the later videos, we are going to do some more problems, and we will carry on with the rest of the chapters of the physics syllabus, and we will continue with this. Sorry, there's one mistake here. It is CT here and CT here also. We have missed that, this factor of of t here. So now it becomes like this. So the average velocity is at square minus bt plus c. So I missed this factor of t here. So that resulted in this error. So the total displacement would be the position. This is at x is equal to t minus x is equal to 0. X at 0, sorry. So this whole thing, x at t minus x at 0, is this quantity. X at t is at cube minus bt square plus ct, and at x is equal to 0, the value of the position is 0 actually, because you just substitute t is equal to 0 here. Then x at t is equal to 0 becomes 0. So then you get this thing, xt minus x0, and that would turn out to be at cube minus bt square plus ct, c capital T, sorry, and then you divide it by the t, and then you will get this answer. Okay, so there was a mistake here. The value, the factor of t was missing. So I think that was a very minor mistake, and you can cover it up, and of course that is what the answer would be like.